Hello dear students, thanks to all for watching my lecture. Today I am delivering my lecture on HSC Physics for student of the English version, first paper chapter 2 vector. Today I will discuss a very special part, representation of vector and different types of the vector. Today I am trying to cover the two special part. One part is representation of the vector. Representation of a vector, okay, and different types of the vector and different types of vector. Different types of vector. My dear students and learner, this two part is very important, okay, for this chapter. At first we have to learn representation of the vector, and then we have to learn different types of vector. So we have two options for representation of the vector. My dear student, I think that all of you clearly understand. My dear student, representation of vector. At first we learn representation of vector, then we learn different type of vector. My dear student, we have two options. We have two options to representation of a vector by applying symbol and by applying diagram. So I am trying to write these two types of the option. My dear students and learners, in case of representation of vector, we have two options. One is by using symbol. This is one kind of the option for representation of the vector. Another option we have by geometric way, by geometric diagram. My dear student, these are the two special part for representation of a vector. In case of applying symbol, when we use by symbol for representation of vector, we have four options. Number one option, in which symbol we can use to representation of a vector. Mainly we use English alphabet, capital letter or small letter. My dear students, if we write capital alphabet, suppose we write A, and we write arrow sign at the top of this letter. Okay, my dear student, this is one of the option for representation of a vector by using a symbol. This is the symbol. Okay, number two option, if we write any kind of the alphabet and write the average sign at the top of this alphabet, then this will be the another way for representation of the vector. Number three option is we write English alphabet and write underline. Okay, this is the third option. And number four option is we write bold letter. Okay, this is the bold letter, any kind of the capital alphabet. Okay, my dear student, these are the four types of the option. Among them, which option will be very helpful for us and which option actually we use. Okay, my dear student, although we have four option, but I think this option is best for us. Why? Because if we use number two option, then these two option can create confusion, because average sign also represent vector and another is represent the average. Okay, because of that reason this maybe create any kind of the confusion for you. Okay, this underline also same things. underline represent, this is the emphasizing anything or any sentence. In case of this we use underline sign, and underline sign also use for vector. So this is also confusing and this is time consuming, my dear students. So this option will be best for us for use vector, okay, or representation of the vector. My dear student, now this is the representation of the vector. In case of representation of unit vector, unit vector, if we represent unit vector, for representation unit vector we use any kind of the small alphabet. Suppose we use I cap and then use cap sign at the top of this small letter. If we write J cap small letter, then we write cap sign. If we write small letter K and at the top we use cap sign, then this is the representation of the unit vector. We also write any kind of the symbol, suppose A and use cap sign. Suppose we write B, cap sign. Suppose we write eta, cap sign. This cap sign only for use unit vector. Okay, my dear student, I think that all of you clearly understand. Okay, now we discuss by geometric diagram for representation of a vector. Okay, how we can do this? Now we have now I am trying to discuss. My dear students, suppose this is a straight line, this is a line. Our measurement will be straight from here. Suppose this is origin, this is origin. Okay, this is origin. Suppose this point is A. Okay, suppose this is 0 and this is 1 meter and this is 2 meter, this is 3 meter and this is 4 meter and this is 5 meter. Okay, my dear student, this is a straight line. This straight line or line we start measurement at point A. This is 0 unit and this is 1 unit, this is 2 unit, 3 unit, 4 unit, 5 unit. Okay, now my dear student, if we have taken a line segment from this line, suppose we have taken from here 4 meter. Suppose we have taken here 4 meter line. Suppose we have taken 4 meter line from this line. So this is the line segment. The name is A and B. We have taken 4 meter from this line. This is the line segment. Okay. If we write at point B arrow sign, then this is the way for geometric way for representation of a vector. This arrow sign represent the direction and A represent the initial point and B represent the terminal point, and A to B is the direction of this vector. We know in case of the vector, a vector always has two things. One is its magnitude and another is direction. This arrow sign represent the direction from A to B, and the length of this line segment represent the magnitude. Suppose A is a initial point and B will be terminal point. Another name of A is tail and another name of V is head. You just remember. Okay, my dear student, this line segment, suppose the length of this line, represent the magnitude of the vector. Okay, as we have taken 4 meters, so 4 meter will be the length of AB, and this 4 meter is the magnitude of this vector, and A to B arrow sign represent the direction of the vector. My dear student, if we have taken 3 meter from this line segment, 3 meter, then this will be the vector. Suppose this is A and this is B. Okay, A and B is a vector. This is the geometric representation. As the length of this AB 3 meter, so this is magnitude of this vector will be 3 meter and direction will be A to B. As the magnitude of this vector and this vector not equal, the magnitude of this vector, suppose this is AB and we just change the initial and final point P and Q. The magnitude of AB vector is 4 and magnitude of PQ vector is 3. As the magnitude of PQ is less than AB vector, so we draw the geometric line short than AB. My dear student, I think that all of you clearly understand. This is very important notation for representation of the vector by applying geometric diagram. When we use geometric diagram, if the magnitude of a vector is big, then we draw big line. If the magnitude of a vector is short or small, then we draw a small line. Okay, I think that all of you clearly understand. If this is a line, this arrow sign represent the direction and the length of this line represent the magnitude. Okay, this is the length represent magnitude and arrow sign to represent the direction. My dear student, I think that all of you clearly understand this part. Okay, if you face any kind of the difficulties, then please write your comment on the comment section, then I am trying to clear you. My dear student, now we go to the second part, different types of vector. Different types of vector. Okay, different types of vector. Different types of vector. At first we learn rectangular unit vector. My dear student, this is very important vector, rectangular unit vector. What is rectangular unit vector? In our Cartesian coordinate system, we use 2 axes or 3 axes. If we use 1 axis, then it will be 1D reference frame, and if we use 2 axes, then 2 axes will be perpendicular to each other. If we use in a coordinate system or Cartesian coordinate system, if we use 2 axes, one is x and another is y, and these 2 axes will be perpendicular to each other, then this will be 2-dimensional reference frame. If we use 3 reference axes, one is x, y and z, this reference frame will be 3D and these 3 axes will be perpendicular to each other. Suppose this is x axis and this is y axis, this is x axis, this is y axis, and this is z axis. My dear student, x, y and z, these 3 axes perpendicular to each other. So this is the 3-dimensional reference frame. Both 3 axes intersect at a point and this is the origin. This is the origin. Okay, suppose this is x, y, z. These 3 axes all the time will be perpendicular to each other. The angle between x and z 90 degree, angle between y and z will be 90 degree, angle between x and y will be 90 degree. My dear student, as our board is 2-dimensional surface, so it is very difficult to draw 3-dimensional reference frame. So at first we write here 2 perpendicular axes. Suppose this is x and this is z axis and this is y axis, or we can write here this is x and this axis y and this is z. My dear student, x and y will be perpendicular to each other and y and z also perpendicular to each other. Okay, you just imagine at the corner of your room, suppose this is your room, you just imagine this is x axis, y axis and z axis. Okay, My dear student, these three axes intersect at a point. The name of this point is O. O is a origin. Okay, O is a origin. The coordinate of this origin will be 0, 0 and 0. Okay, all the measurement will be straight from here. My dear student, from the origin, this is the positive side of x-axis, this is the positive side of y-axis, and this is the positive side of z-axis. Here also here has positive side, here also has negative side of x-axis. If this is the positive side of y-axis, in this direction, here has a negative side. If this direction is positive and downward direction is a negative. My dear student, in our Cartesian coordinate system, we use three perpendicular axes. One is x-axis, another is y-axis and z-axis. These three axes will be perpendicular to each other. Along these three axes, we use three unit vector. Along the direction of the positive side of x-axis, we use unit vector I cap. Along the positive side of the y-axis, we use unit vector j cap, and along the positive side of the z-axis, we use unit vector k cap. Along the positive side of the x-axis, we use I cap. Along the positive side of y-axis, we use j cap. Along the positive side of z-axis, we use k cap. My dear student, these three unit vector I cap, j cap and k cap is called rectangular unit vector. What is the definition? In our Cartesian coordinate system, we use three positive axes x, y and z, and along the positive side of x, y, z, we use three unit vector I cap, j cap and k cap. The name of this three vector is called rectangular unit vector. My dear student, I think that all of you clearly understand. Now we learn another vector, positional vector. Number two, positional vector. Positional vector. What is positional vector? Positional vector is nothing but, suppose this is a 3D coordinate system and this is the origin. Suppose here has a point 2, 3, 4. Okay. If any vector identifies this point, suppose this is a vector, this is a vector, the name of this vector is called a vector. If a vector identify 2, 3, 4 coordinate system or this point with respect to the reference frame, with respect to the origin of the reference frame. If any kind of the vector identify any kind of the point with respect to origin of a reference frame, then the name of this vector will be positional vector. Suppose if here has a point, suppose there has a point 4, 2, -3. If we use a vector, then this is also a positional vector. Why B is a positional vector? Because B vector identify 4, 2, -3 point with respect to the origin of a reference frame. So A and B is positional vector, is called positional vector. My dear student, I think that all of you clearly understand. Okay, now we move another vector, displacement vector. Number three, displacement vector. Displacement vector. What is displacement vector? We just try to understand. Suppose if we draw a two-dimensional reference frame, suppose this is x-axis and this is y-axis. This is the origin. This is origin. The coordinate of this origin will be 0, 0. Along the positive side of the x-axis, we use unit vector I cap. Along the positive side of the y-axis, we use a unit vector j cap. Suppose here has a point. Suppose this point is 2, 4. Okay. If we use a vector to identify this point by this vector, then this will be a positional vector. R1 is a positional vector. Why R1 is a positional vector? Because with respect to the origin of a reference frame, this R1 vector identified 2, 4 point at first. As R1 vector, R1 positional vector identified 2, 4 point at first, so we can write this is the initial point. This is initial point. Okay. If here has a point, suppose this point is 4, 3. If another positional vector identify this point by R2 positional vector, at first we identify this point, then we identify this point. So this is the terminal point. Terminal point. Why we call this point is a terminal? Because at first we identify 2, 4 point by using positional vector R1, then we identify 4, 3 by using R2 positional vector. My dear student, what is displacement? At first try to understand. Displacement is nothing but it is one kind of the shortest distance between initial to final point. In our previous lecture already we discussed. Okay, my dear student, this is, if this is the initial point and this is the final point, then this will be the shortest distance between initial point to final point, and this vector is called displacement vector. Displacement vector. The definition will be, after changing the position of vector, we get a vector. The name of this vector is called displacement vector. That means after changing the positional vector, after changing a positional vector, a vector is created. The name of this vector is called displacement vector. How we can find out the displacement vector? It is very easy to find out this displacement vector. Suppose if R1 is a positional vector, suppose R1 is a positional vector. How we can find out this vector? It is very easy to find out. Okay, for identify R1 vector, we have to develop a knowledge. What is our knowledge? Suppose 2 is a scalar quantity and 2 is a number. 2 cannot represent anything. Why? Because 2 is a number. If we add Newton unit after 2 number, then now 2 represent it is a force. Okay, why now 2 represent is a force? Because we use unit. But if we call this 2 cannot represent anything. Now this is number. Okay, after 2, if we use meter per second, now 2 represent velocity of something. Okay, after 2, if we use meter per second square, then now 2 represent the acceleration or deceleration. In the same way, my dear student, if we use unit vector, in our previous section we learned rectangular unit vector. Along the positive side of the x-axis, we use unit vector I cap. Along the positive side of y-axis, we use unit vector j cap. Along the positive side of the z-axis, we use unit vector k cap. My dear student, this is the 3 unit vector is very special. The direction of I cap unit vector will be positive side of x-axis, and direction of j cap will be positive side of the y-axis, and direction of k cap vector will be positive side of z-axis. Now if we add here I cap, now 2 represent a vector. Why? Because we use here unit of a vector. As we use unit of a vector, so now 2 I cap represent a vector. If 2 I cap represent a vector, then a vector has two things. One is its magnitude and another is its direction. 2 represent the magnitude, and I cap represent the direction. My dear student, I think that all of you clearly understand. Okay, now if this is the positive side of the x-axis, suppose we start measurement from here. This is 1 unit and this is 2 unit. If we take a arrow sign, this will be the representation of vector, by applying geometric way. The length of this line is 2. 2 is the magnitude, as the direction is positive side of x-axis. So here as a unit vector I cap, so we multiply 2 I cap. Now 2 I cap represent this vector. Okay, my dear student, I think that all of you clearly understand. Now we want to write R1 positional vector. How we can write this or find out this R1 positional vector? We can easily find out. We just try to understand. 2 is a value. If we want to go 2, 4 point, then we must have to start journey from origin. Along the positive side of the x-axis, we must have to go 2 unit. So we use here 2 and add here I cap. Okay, I think that all of you clearly understand. Okay, then 4 represent the positive side of the y-axis. 4 represent the value positive side of the y-axis. So as this is the positive, so we write here positive. Then along the positive side of the y-axis, we use a unit vector. The name of this unit vector is j cap. So we easily find out the positional vector R1. This R1 vector now represent the position 2, 4. In the same way, if we find out the R2 positional vector, as here we can see 4. 4 is a value along the positive side of the x-axis. So we write here 4. As along the positive side of the x-axis, we use unit vector I cap. Now 4 turn it into vector after adding I cap vector. Okay, unit vector. Then we can see here 3. 3 is a value along the positive side of the y-axis. As this is the positive, so we write here positive. Then we write 3, as this 3 represent the value along the positive side of the y-axis. So we use here unit vector j cap. My dear student, I think that all of you clearly understand. Okay, now how we can find out this displacement vector? As this is a triangle, by applying the triangle law, we can easily find out the displacement vector. Before find out the displacement vector, at first we have to learn triangle law. Suppose O, this point A and this point B. Okay, suppose triangle OAB. If we use a triangle law, then we can easily find out del R vector. In our vector, there are 5 types of the geometric addition of vector. How many types of geometric addition? 5 types. One is general law, another is triangle law, third one is polygonal law, fourth one is parallelogram law, and 5th one is component law. There are 5 types of the option for geometric addition of vector. My dear student, how we can apply this triangle law? Suppose if this is the triangle, here we can see R1 is a vector. This is the initial point and A is a terminal point. And AB is a displacement vector. The initial point of the displacement is at point A and terminal point of displacement vector is B. Okay. If the initial point of a vector and terminal point is same point, then these two vector is same order. Suppose this is a vector, this is initial and this is terminal, and another vector, if another vector initial point is put on first vector, then this is the same order. This is the same order. My dear student, I think that all of you clearly understand. But if terminal point of the two vector is same, then this is the opposite order. Okay, opposite order. Okay, we just R1 vector and del R vector as represent the same order, so we write R1 vector plus del R vector. As R2 vector represent the opposite order, so R2 vector will be the resultant vector. My dear student, I think that all of you clearly understand. If 3 vector represent the side of a triangle, if 2 vector represent same order, R1 and R2 is the same order. Why R1 and R2 is the same order? Because the terminal point R1 has the initial point of del r vector. So r1 vector and del r vector is the same order, but if we see r2 vector, the terminal point of r2 vector and del r vector is same point, so r2 represent the opposite order. If the 3 vector represent the side of a triangle, the same order of the 2 vector is summation, and opposite order that vector represent the third side. This third side opposite vector represent the resultant of this 2 vector. My dear student, if we change the side, then we get the del r, that means displacement vector. After changing the side, we get r2 minus r1. r2 minus r1, if we put the value here, then we get the value of displacement vector. r2 is 4 I cap plus 3 j cap minus r1 is 2 I cap minus 4 j cap. If we have take common I cap, then we get 4 minus 2 I cap plus, if we take common j cap from this 2 part, then we can write 3 minus 4 j cap. My dear student, this is the special rules to find out the displacement vector. Okay, displacement vector. My dear student, this we can also use to find out any kind of the vector if we know the initial point and final point. Okay, suppose if we find out this displacement vector, 2, 4 is the initial point and 4, 3 is a terminal point. Okay, what is the rules to find out this vector? We can use this way for written problems. After solving the written, we must have to write this triangle law. But if we solve the MCQ, then we can use this law for MCQ, find out any kind of the vector. If we want to find out displacement vector, as we know, this is the initial point and this is the terminal point. So you just see this formula very deeply and carefully. 4 is a value of terminal point of this displacement vector, 4. So at first we write 4, then 2 is the initial point of this displacement vector, terminal point minus initial point. As 4 represent the positive side of x-axis and 2 also represent the positive side of the x-axis, so this after minus 4 and 2, this is the value of change of x along the positive side of the x-axis, so we use I cap here. Then we write plus sign, then again we at first write the terminal point of the displacement vector. The terminal point is 3, we write here 3, we write minus sign, then we write initial point is 4. As this value represent the positive side of the y-axis and this 4 also represent the positive side of y-axis, so this 3 minus 4 represent the change of the value of y, as this is the y-axis, so we use here unit vector j cap. So this is the special way to find out any kind of the value of a vector. If we know the initial point, suppose if this is a vector, the initial point is A and final point is B. Suppose this point is 2, 3 and this